Hello everyone, my name is K. Rajesh. I am from CSC C section. Today's my topic is about interrupts control system. Introduction. The interrupt is a signal emitted by hardware and or software when a process or an event needs intermediate attention. It alerts the processor to a high priority process requiring interruption of the current working process. In I/O devices, one of the bus control lines is dedicated to this purpose and is called as interrupt service route line. When a device raises a interrupt at a, let's say, purpose I, the processor first completes the execution of instruction I. Then it loads the program counter PC with the address of the first instruction of the ISR. Before loading the program counter with the address of the interrupted instruction is moved to a temporary location. Therefore, after handling the interrupt, the processor can continue with process I plus 1. While the processor is handling the interrupts, it must inform the device that its request has been recognized so that it stops sending the interrupt request signal. Also saving the registers so that the interrupts process can be restored in the further increase and a delay between the time an interrupt is received and the start of the execution of the ISR. This is called interrupt latency. Types of interrupts. Basically, interrupts are of two types: hardware interrupts and software interrupts. And hardware interrupts are of two types: maskable interrupt and non-maskable interrupts. Hardware interrupts. In the hardware interrupts, all the devices are connected to the interrupt request line. A single request line is called for all the end devices. The request To request an interrupt, a device closes its association switch. When the device requests an interrupt, the value of INTR is the logical OR of the request from individual devices. The sequence of events involved in handling an IRQ. Devices raise an IRQ. The processor interrupts the program currently being executed. The device is informed that its request has been recognized and the device deactivates the request signal. The requested action is performed. An interrupt is enabled and the interrupted program is resumed. Handling multiple devices. When more than one device raises an interrupt request signals, then additional information is needed to decide when which device to be considered first. The following methods are used to decide which device to select: polling, vectored interrupts, and interrupt nesting. Polling. In polling, the first device encountered with the IRQ bit set is the device that is to be served first. Appropriate ISR is called the service service the same. It is easy to implement, but a lot of time is wasted by interrogating the IRQ bit in all devices. Vectored interrupts. In vectored interrupts, the device requesting an interrupt identifies itself directly by sending a special code to the processor over the bus. This enables the processor to identify the device that generated the interrupt. The special code can be started address of the ISR or or when the ISR is located in memory and is called interrupt vector. Interrupt nesting. In this method, the I/O device is organized in the priority structure. Therefore, the interrupt request from the higher priority device is recognized, whereas a request from the lower priority device is not recognized. The processor accepts the interrupts only from devices or processes having priority. Therefore, an interrupt request from the higher priority device is recognized, whereas a request from the lower priority device is not recognized. Processor's priority is encoded in a few bits of PS. PS stands for Process Status Register. It can be changed by program instructions with that write into the PS. The process is in survived mode only while executing OS routines. It switches to user mode before executing application program. Software interrupt types. Normal interrupts. Normal interrupts means the interrupts which are caused by software instructions are called software instructions. Exceptions. Unplanned interrupts while executing a program is called exceptions. For example, while executing a program, if we got a value which is divided by 0 is called an exception. Interrupt handling. If there is an interrupt in instruction cycle, then it will trigger the interrupt handler. The handler will stop the present instruction which is processing and save its state in the PC program counter register and load the state of the interrupt program. Uh, OS serves the interrupt from interrupt vector table through service routine. Interrupt handler. If there is a interrupt in instruction cycle, then it will trigger the interrupt handler. The handler will stop the present instruction uh, which is processing and save the state in the program counter register and load the state of the interrupt program. OS serves the interrupt from interrupt vector table through interrupt service routine. After processing the interrupt handler will load the instructions of previous saved processes from the register. Process will start this processing where it's left. This saving the old instruction processing configuration and loading the new instruction configuration is also called as context switching. After processing the interrupt handler will load the instruction of previous saved processes from the registers. Process will start its processing where it left. This saving of old instructions, processing configuration, and loading the new interrupt configurations is called the context switching. Thank you.